Hello everyone, I am I am going to discuss about new chapter which is FET and its biasing. So as we discussed earlier that transistor, that means it is transfer resistance from input to output. That's why it is known as transistor. So here FET is another type of transistor. In this topic, we are going to discuss about its types and its symbol and its construction. So let us start with its basic classification. Here we can see this is the classification of transistor. It is classified into two types. Number one, it is BJT, and number two, it is UJT. BJT stands for bipolar junction transistor. As we discussed in chapter number 2, that the conduction takes place due to both holes and electrons. That's why it is known as bipolar junction transistor, and its types are NPN and PNP. Whereas a UJT, it is known as unipolar junction transistor. In UJT, the conduction takes place due to only majority carrier charges. It might be holes or might be electrons. So according to this, it is divided into two types. Number one is JFET and number two it is MOSFET. JFET stands for junction field effect transistor and MOSFET stands for metal oxide semiconductor field effect transistor. So today we are going to discuss about only FET and its types. FET stands for field effect transistor. So here, as we discussed earlier, that what is transistor? It is transfer resistance. So two words combined, transfer plus resistor, makes transistor. Now, as we discussed earlier, that UJT, that means unipolar junction transistor, in FET, conduction takes place due to only majority carrier charges. So it might be holes or electrons. That's why it is known as unipolar junction transistor. So here it is bipolar and here it is unipolar. Now in this topic we are going to discuss about unipolar. So here we can see this is the FET construction and its symbols. So FET construction, and here it is the symbol. As we discussed in BJT, there are three different types of terminals: base, collector and emitter. Similarly here in FET, there are three types of terminals, which is known as drain, another one is gate, and last one is source. So drain, gate and source are the terminals for the FET. So here we are going to apply voltage across gate and source. That means it is also known as VGS, gate to source voltage. So potential difference between gate to source is our input voltage. And accordingly we will get output current from that IT, which is represented over here. Now, next we are going to discuss about symbols. Here we can see these are the two symbols for FET. FET symbol first, this is the, here we can see this is the N channel, and here we can see this is the P channel. Let us discuss about P channel. Here arrow's indication is outside. Here clearly we can see arrow goes outside, so that means it is known as P channel JFET, or we can say it is FET of P channel. And its terminals we can see drain, gate and source respectively. Similarly here in N channel we can see drain, gate and below source. But here we can see the arrow indication is coming inside. So that's why it is known as N-channel JFET. So this is the difference between N-channel and P-channel JFET. Now let us discuss about why FET called as voltage control device. As we discussed earlier for BJT, which is known as current control device, whereas here it is known as voltage control device. FET is controlled by an electric field created by external voltage, as we discussed in first, that VGS. That means it is gate to source voltage is our external voltage supply, or we can say it is our input voltage supply. In detail, depletion regions set around the P region are controlled by the negative gate voltage to control the drain current. This is called as field effect transistor. Basically here field is generated between the N channel and P channel, N type and P type, and due to this channel, or we can say this is due to this depletion region, we can control the flow of current, which is known as field effect transistor. That's why it is known as FET. In JFET, the channel and gate terminal is electrically connected. So channel and gate terminal is connected electrically. More detail we are going to discuss about particular topic which is known as N-channel JFET and P-channel JFET. So field effect transistor, which is known as FET, is a type of transistor which uses an electric field to control the flow of current. So there are three different types of terminals as we discussed. One is source, second one is gate, and another one is drain. FETs control the flow of current by application of voltage to gate, which in turn alters conductivity between the drain and source. So this is the working principle of FET. Here, this is the advantages of FET over BJT. FET has a very high input resistance, which is in mega ohm. It might be 100 mega ohm. FET has better thermal stability. So that's why we are using over the BJT. It can operate at much higher frequency as compared to the BJT. It produces lesser noise, lesser internal noise, we can say precisely, that generated in BJT. It is unipolar device, so depends on flow of majority carriers only. So there are no holes and electrons combination, but here only majority carrier charges flows, and that's why it is known as field effect transistor, or we can say UJT, unipolar junction transistor. It is in smaller size compared to the BJT. And the most important thing, thermal runaway. Thermal runaway can damage BJT, but it is not taking place in FET. So this is the main advantage of using FET. Here this is the classification of FET. So FET, that means field effect transistor, which is divided into two parts. Here we can see one is JFET and another one is MOSFET. So JFET, that means it is junction field effect transistor, and MOSFET, that means metal oxide semiconductor field effect transistor. So in this chapter we are going to discuss thoroughly about this JFET, thereafter MOSFET and its other types. So this chapter contains these different types of theories. So here we can see FET is divided into JFET and MOSFET. So JFET is divided into two parts. Number one is known as N-channel JFET and other one is P-channel JFET. N-channel JFET, that means majority carrier charges are only electrons. And here P-channel JFET, that means majority carrier charges are holes. And due to majority carrier charges, current flow in FET. So it is known as N-channel or P-channel JFET. Similarly here we can see MOSFET. MOSFET is divided into two parts. One is depletion MOSFET, it is also called as D MOSFET, and another one is E MOSFET, that means enhancement MOSFET. Next, where we are going to use FET. So FET is commonly used in MOSFET. So the most commonly used FET is the MOSFET. The CMOS, which is known as complementary metal oxide semiconductor, which is process technology, is basis for modern digital integrated circuit. That means we are going to use chip, or we can say ICs, in the form of CMOS. So in that CMOS we are going to use MOSFET. Other than, as the devices are typically but not always built symmetrical from source to drain, this makes FETs suitable for switching analog signals between the paths. That means we are going to use it in multiplexing techniques. So in multiplexing, FET is also used. So these are the introduction of field effect transistor and its types. So that's all for today's lecture. If you have any queries related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lectures. Thank you.